Okay, sorry for the super choppy ending on the notes thing, but I was not going to have enough time to get through this all in one shot, and I didn't want it to be choppy. So with a new video, we're going to go through the book questions, do a couple of examples so that you can know what we're doing for 9.1 with line graphs, or line plots, sorry. Okay, so you should be on page 533, which is the front page, and we are actually going to walk through this example because it's really good, and it's going to show you what to be doing for the rest of the problems. Okay, we're going to start by reading the question up here, which says, students have measured different amounts of water into beakers for an experiment. The amount of water in each beaker is listed below, and then here's our data set. Looks like they've started a line plot for us, but I don't think it's finished, so we're going to have to finish that line plot over there for us. Okay, here's the question. If the total amount of water stayed the same, what would the average amount of water be in a beaker? Now, before we even get started with the math here, I want to highlight a word. Average. We're going to be looking at that word really closely, closer to the bottom of the page, and we're going to be understanding what that word means. But until then, let's just keep going with what we already know. So the first thing we're going to look at, oops, here we go. The first thing we're going to look at is step 1. Count the number of cups for each amount. Draw an X for the number of times each amount is recorded to complete the line plot. Okay, so they started it for us already. I see a 1/4 cup, a 1/4 cup, and 2 more 1/4 cups. They didn't do theirs in order, which makes it a little trickier. They also did a 3/4 cup. So these are the ones that we have left to put on our line plot. So we need a 1/2 cup. We need another 1/4 cup. Scroll up a little bit so I have more room. We need another 1/2 cup. Another 1/4 cup. A 3/4 cup. A 1/4 cup. And a 3/4 cup. Alright, so now using this information, you can't see those down there, but it says count the number of times, or the number of cups for each amount. So 1, 2, 3, 4, 5, 6, 7 for 1/4. How many for 1/2? 2. And then for 3/4 there are 3. Okay, step 2. Find the total amount of water in all of the beakers that contain 1/4 cup of water. So this would be like if I had a whole bunch of beakers here and they each had 1/4 in it. Instead of adding up 1/4 plus 1/4 plus 1/4 plus 1/4, it'd be a lot faster to do something else. What would it be faster to do? If you said multiply, then you're absolutely right. Thinking back to our notes page here, let's see if I can get that pulled up. Here we go. Thinking back to our notes page. Oh, I just went past it. Here we go. Sorry. Here we go. To find the total amount, multiply each fraction by the number of times it shows up. So we're going to multiply each fraction by the number of times it shows up. In this case, it was 7. 7 beakers that had 1/4 of a cup. So there are how many fourths? If I write a little math equation here, 7 times 1/4, put 7 over 1, do a little multiplication, 7 times 1 is 7, 1 times 4 is 4, so there are 7 fourths, or written as a fraction, 7 over 4. But now I've got an improper here. Got to take care of that, do a little simplification. How many times does 4 fit into 7? Only goes in 1 time because 2 times 4 is 8, and that's too big. So 1 times 4 is 4, so we take that away from the 7. 7 minus 4 is 3. Keep your denominator. So there are 1 3/4 cups total for all of the beakers that hold 1/4. Okay, let's do steps 3 and 4. Find the total amount of water in all of the beakers that contain half a cup of water. So there are 2 beakers with half a cup of water. So we're going to do the same thing we just did up here on step 1. Write yourself a little multiplication. Do the fraction times the number of times it shows up. Put the whole number over 1. 2 times 1 is 2. 1 times 2 is 2. So there are 2 halves, this number right here, 2 halves, or 2 over 2, which is 1 cup, because remember, anytime the numerator and the denominator are the same, it's 1 whole. Okay, step 4. Find the total amount of water in all of the beakers that contain 3/4 cup of water. Now they're wanting you to do it by yourself. What do we do to figure this out? They kind of wrote down the multiplication for you already. If we look up at our chart, there were 3 of those, which is where this number came from. 3 times 3/4. Put your 3 over 1. 3 times 3 is 9. 1 times 4 is 4. And now I have to simplify. How many times can 4 go into 9? Goes in 2 times. 4 times 2 is 8. I'm going to subtract out what we already have. 9 minus 8 is 1. Keep your denominator. Okay. Now if I want to find the total amount of water, add to find the total amount of water in all of the beakers. So they took the 1/4 plus the 1/2 cups plus the 3/4 cups. That's what these numbers are all. This is what we found here. Found a hole there and 1 3/4 from the top. They, conveniently, it's already in common denominator for us, so we don't have to do anything with that. Add fractions first, and feel free to stack them up if that's easier for you to see. It's certainly easier for me. So I'm going to stack them up here. Add those up. 3/4 plus 1/4 is 4/4. Add my whole numbers, 2, 3, 4. 4 and 4/4. Now what do we know about that? We've got a numerator and a denominator that are the same. That becomes another whole. So 4 plus 1 is 5. So there are 5 cups of water total. And that's what we did on our example. We times the fraction by the number of times it showed up, added them all together, and got our final answer. Okay, step 6. This is where the average comes into play. Basically, what average is where you take everything that you found so far, you add all of those up, and then you divide by the number of beakers altogether, or by the total number. So you have all of whatever you found divided by the number of things that you have. So here, we count these. I'm going to use a different color so you can see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 total things, and I found the amount of water to be 5. If I want to find the average amount of water in each beaker, I would take 5 and divide it by 12. And this goes back to one of our lessons from chapter 8, where we have a division sentence like this. What can we make that look like? We can make it look like a fraction. So I could put 5 over 12 and have 5/12. Now I have to think about that. Is that in simplest form? Is there anything that goes into 5 and 12? I can't think of anything. So the average amount of water in a beaker is 5/12 of a cup. So whenever you see this word average, that means you find the total first and then divide by how many things you have. So in this case, by the number of beakers, I'm just going to circle by the number. You divide your total by the number of things that you have. Okay, hang with me. We're going to go ahead and do number 1 together because it's going to be pretty much the same thing. Well, I mean numbers, I guess 1 through 4, this first one. Okay, the directions say use the data to complete the line plot, then answer the question. So we're just doing what we did on the example page. Oops. Oh, for crying out loud. Sorry, this is not working well for me. There we go. Okay. Liliana needs to buy beads for a necklace. The beads are sold by mass, which is how much is in it. She sketches a design to determine what beads are needed and then writes down their sizes, and the sizes are shown below. So here's our data set. Complete the line plot, figure out the questions. So the first thing we have to do is fill out this plot. They did 3/1/5 for us. I'm going to cross out 3/1/5 because they're already used up. Okay, then there's a 2/5 and another 2/5, a 4/5, a 2/5. I always cross it out after I'm done because if I cross it out before, then if I forget what I was doing, I don't know where I'm at. 3/5, 4/5, 2/5, 3/5, whoops, 3/5, and 2/5. Okay, so there's our line plot. Pretty easy to go ahead and build one of those, isn't it? Okay, first question. What is the combined mass of the beads with a mass of 1/5 of a gram? So we're just looking at these ones here for right now. Think, there are how many x's above 1/5? 1, 2, 3. Just using your data or your chart to help you. So the combined mass of the beads is how many fifths or how much of a gram? In this case, we times the fraction by how many are above it. Put that whole number over 1. 3/5. So there are 3/5 or 3/5 of a gram. Okay, so we're just using our line plot here. So we're just using our line plot to figure out, I don't know where that all went, but it doesn't really matter. You have it. Okay. What is the combined mass of all the beads with a mass of 2/5 of a gram? So now we're looking at the 2/5, same thing, times the fraction by the number of x's above it. 1, 2, 3, 4, 5. 5 over 1, 2 times 5 is 10, 5 times 1 is 5. Improper fraction now. How many times does 5 go into 10? 2. What is the combined mass of all the beads of the necklace? So this is the part of the show where you take each one, 1/5 times 3 gives you something, 2/5 times 5 gives you, in this case, 2, blah, 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 and that would be your total. Add those all up. And then the average, this would be where you use this number and divide it by the total number up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So whatever this number is divided by